The beautiful hills overlooking the Danube are perfect for viticulture. Here the grapes grow on sandstone terraces. The terraces provide the necessary nutrients and they make sure that the grapes receive enough sunlight. And grapes need loads of sunlight. A special heat index captures the bioclimate at vineyards. The heat index sums up the average daily temperature during the growing season from April to September. Here, at the Danube, the heat index reaches values of up to 2100, well above 1500 necessary for viticulture. How do we find the heat index for a location? Well, when there is a weather station, that's straightforward. We simply collect temperature measurements from April to September and measure the heat index directly. But what about locations without weather station? How can we find the heat index for these?
Since near things are more related than distant ones, we can predict the heat index for any location from its neighbors. This is called spatial interpolation. The most common spatial interpolation method is inverse distance weighting, or IDW. For IDW, we first define a search neighborhood for the point we want to interpolate. The search neighborhood either comprises neighboring locations within a specific distance or the k nearest locations, say the 5 nearest locations. In the search neighborhood, we weigh each measured heat index inversely proportional to its distance to the interpolated point. Close-by points get stronger weights than more distant ones. The weighted average of all heat indices in the search neighborhood gives the interpolated heat index for the location without measurements. Inverse distance weighting is just one of many spatial interpolation methods. They all use the first law of geography to predict a phenomenon at a location without measurements.
And that's how the first law of geography can help us to tell whether climate is suitable to grow wine.